Now, adding and subtracting rational functions is quite a great deal more complicated than multiplying and dividing. Just like with fractions, the rules are a little bit more annoying, again, just because. So, like when it comes to, like, let's start off with a simpler case. What happens when we're adding fractions with the same denominator? Let's say we had 7/4 minus 1/4. Remember that the rule of thumb is that if it is the same denominator, what I do is I add or subtract across the top. So what I would have here is, well, 7 minus 1 is 6, and that would be it. And remember, when we do that, the denominator will remain the same. And of course, after I finish, I would always think about, well, can I simplify the answer? That's always the step at the end, is after I combine them together, cancel any common factors, simplify your result. And again, the reason this is true is because fractions will only combine when they have the same denominator. It's like trying to take pieces of a pie. If you have 7/4 of a pie, that would mean you have 1 3/4, and you ate 1/4 of the pie, you'd have, well, 1.5 left, because, you know, you could draw a diagram and say when it's the same size, it's easier to tell by comparison. But when the denominators are different, that comparison can't be made. Excuse me. So let's do an example. So when we're dealing with rational functions, again, if we have two different rational functions, when the denominator is the same, you can add it. You're allowed to add and subtract. What we say is that when the denominators are not the same, you're not allowed to add them in that form. Technically, you can add them, but it won't work. You have to do work before you get going. But in this case, it's the same on bottom, so I'm allowed to do it. And basically, again, how it will work is I want to take the first numerator and subtract the second numerator. And since subtraction means the entire thing is being subtracted, there's an implied parentheses around the secondary component. I could think about this as 6x squared plus x minus the whole entirety of x squared plus x plus 20. So basically, the distributive property will apply here into the numerator, and each one of those will become a negative. So what this would leave me with is, well, 6x squared minus x squared would be 5x squared. X minus x will actually cancel, and then 0 minus 20 will be minus 20 on top. And then that will be all over the original denominator, x squared plus 3x plus 2. Then after I combine them, then I could think about, well, does factoring this help me at all? Because we always want to consider, does this simplify? Here on the top, I have a common factor of 5, which would leave me with x squared minus 4. And x squared minus 4 factors as a difference of squares. And then the denominator is a trinomial. That should be x plus 2 times x plus 1. And I tried to use some easier polynomials here just for, and usually with your homework, it's not going to be super impossible to find them. In chapter 5, I tried to give you more difficult polynomials to factor, just because it's important to know how to do anything. But usually, from what I've found in the chapters on rational functions and expressions, they tend to give you ones that aren't super bad, because we're more focused on the ideas of fractions and applying them to polynomials. It's not, technically, we still need to know how to factor. And what we can see is that we have a common factor of x plus 2. So ultimately, our answer will reduce down to 5x minus 10 over x plus 1. And that would be the result of our subtraction problem. So again, the idea is we got to combine them with the common denominator. Once we do that, we want to factor. So you don't want to factor first. That's the thing. That's what's kind of different about these. With multiplying and dividing, you always want to factor before doing anything. With subtracting, well, sometimes you do want to factor. We're going to get into that. But when the denominator is the same, we don't need to factor it. That will actually make it more difficult to combine them together.